Hello, today we are going to solve the problem of the date from LeetCode. In this case, we need to design a circular deque, and they are giving us some methods that we need to implement. This deque will have a fixed maximum size of k. Then we need to implement the methods following the given conditions. Like to insert in the front of the deque or in the last, and also to remove from the front and from the last. And according the conditions given, like if it's not possible to delete or insert, we should return a boolean. And then also we need to be able to return the front and the rear. And yeah, then we also need to implement methods to check if it's empty or it is full, or if it's full. Okay, for this we are going to reuse some of the methods, because for instance, at the moment of inserting, it will fail if it's already full. For the reason, we can reuse that method. And at the moment of deleting, also it will fail if it's already empty. And the main idea that I have used to perform this implementation is using a vector and the two-pointer technique. Basically, I will use like one index to know what is the front of the queue, and also another index to know what is the last index, the last element index. And then, according to the operations, if they are insert or removing, I am going to like move these pointers accordingly. For instance, for the front, if there is an insertion, then I will move it, like increase the value of the iterator. And if it's a remove, I will decrease the value of the index, and I will do the contrary for the last. Okay, then it's important to know that at most will be this number of calls. That means that in the worst scenario, where only insertions are done, for like let's say insertions to the front or insertions to the last, then we can initialize, or let's say your container or vector, with the double of this size. In that way, it doesn't matter if, like in the worst case, all the elements are appended to the front or all the elements are appended to the last. Because also that's another thing that I did not mention, is that the initial value of my two pointers will be the same. Let's say to the last pointer and front pointer will be at the same value, that is the middle of the array. And if there is an insertion in front, then I will move, I will increase the front pointer, and then if it's a front delete, then I will decrease the pointer, and then if it's a last insert, I will, like I mentioned, the other way around, I will decrease her, because it will move to the other side of the vector. And if there is a last insert, then the last pointer will be increased. And when we can, I think, start with the implementation. Let's put max length. That will be for this number, 4,000. And then we also will need a variable for the front pointer, and also a value for the last pointer. Then we need a value also to maintain the length of the queue. And then also we need to store k, because we need to check when the the queue is full. Then I am going to start also the value of k. Also, it's important to have our internal structure to store the data. Let's save it as data, and let's initialize this with the max length. And then we need to initialize our pointers. Let's create a method or put reset pointers. Will be at the middle of the max length. Okay, then we can start with the implementation. Then before doing an insertion, first we need to check if it's already full. Then if it's already full, we cannot perform any insertion. Then also it's important to know that, like, for the first insertion in or the queue after it's empty, we need to handle especially the pointer, because like for the first element, when let's assume that before this insertion or the queue is completely empty, for the first insertion we don't need to move our pointer because we can override the current pointer, let's say, value, because it's empty or list. For that reason, we also need to check that. If it's not empty, then I will need to increase the front pointer if it's not empty. But if it's empty, I can write using the same pointer without increasing it previously. But if the queue already has elements, yeah, I need to do this increase, because otherwise I will override values. Also, I need to increase the length. Then we return true because it was possible to perform the insertion. Then for the insert class, we'll reuse this. The same condition will apply, but in this case, like I mentioned, the last pointer will go in the other direction. For that reason, if it's not empty, we need to like move it to the other direction. Then delete. Before performing any delete, we need to check if it's not empty. Well, if it's empty, we can return already false, because it won't be possible to perform any deletion. The same logic for this. And then we need to, because we are deleting from the front, then we can move our pointer to the other direction that we are using to increase. To increase, we are increasing the value, then to delete, we should decrease the value of the pointer. And then we also should decrease the length. Then basically the opposite operation for the last pointer, because like the directions are inverse. Then for get from, we need to check if it's empty, then we cannot return anything because it's empty. And if not, we should return the element that is in the front pointer position. We need a similar logic for this, but we should use the last pointer here. Then if it's empty, it's obviously that only we need to check the length, and if the length is 0, then this will be the answer. But In this case, it's a bit special because every time that we reset or the queue, or like we know that it's already empty again, it's important to reset the pointers. Otherwise, they can be in values that in positions that are not the best or could cause errors. But this we only should be applied if it's empty. Let's say, let's call it the queue empty, and then we should return the queue empty. Then if it's full, we only need to check if the length is equal to k. Okay, then let's send this. Let's see if this works. Okay, then let's submit. Okay, I hope that the explanation was clear. If not, let me know in the comments. Thank you.